In episode 45, titled Administer PKI, Certificates and Practical Trust Models, we present public key infrastructure as the trust fabric that enables authentication, encryption, and signatures across everything from browsers and APIs to devices and code. PKI is not a single server or one vendor product. It is a set of roles, keys, certificates, policies, and audited procedures that let strangers verify who is speaking and whether the message was altered. When it is administered well, identities bind to keys with predictable assurance, secrets travel safely, and signatures mean something in court and in compliance reviews. When it is administered poorly, outages bloom at certificate expiry. Debugging becomes folklore, and trust erodes quietly until the day a trivial mistake takes a business-critical service offline. At the core sits a certificate authority hierarchy with distinct duties and explicit boundaries: the root, the intermediates, and the issuing tiers. A root certificate authority must live offline under controlled ceremonies because it is the ultimate trust anchor. If that key walks, the entire hierarchy collapses. Intermediates carry the authority to sign and entities or other intermediates within defined profiles, letting you compartmentalize risk, rotate tiers, and delegate operations safely. Issuing CAs handle day-to-day enrollment, revocation, and renewal. Each tier should have written roles, physical and logical isolation appropriate to its power, and measurable controls that auditors can verify. The payoff is simple. Compromise at a lower tier does not destroy the tree, and recovery becomes rotation and revocation rather than prayer. Certificates themselves need profiles that encode purpose, constraints, and hygiene in a way both machines and people can apply. Define server authentication profiles with subject alternative names bound to host names or service names, appropriate key usages, and extended key usages, EKUs, for server auth. Define client authentication profiles that constrain to client auth and restrict what names and attributes may appear. Define code signing profiles with explicit EKUs, higher assurance for issuance, and lifetimes aligned to update cadences and revocation realities. Lifetimes should be short enough to bound risk and long enough to avoid self-induced outages. Naming standards must match inventory truth and avoid wildcards except where a business case survives a blast radius discussion. Profile discipline keeps issuance consistent and validation unambiguous under pressure. Automated enrollment is how PKI becomes usable at scale without turning engineers into clerks. Use protocols such as ACME for servers and gateways, SCEP for legacy device ecosystems, or EST, where stronger mutual authentication and modern ciphers are required. Whatever protocol you choose, make strong validation non-negotiable. Domain control validation for public names, service ownership checks for internal names, device attestation or bootstrap trust for hardware identities, and change approvals tied to real owners. Record exactly which signals unlocked issuance and keep those records for forensics and audits. When automation is paired with rigorous validation, certificates arrive on time for the right subjects and the help desk queue gets quieter every month. Revocation mechanics often remain vague until the day you need them. Treat them as first-class operations from the start. Certificate revocation lists, CRLs, remain useful for batch consumption and long-tail clients, but their latency and size argue for shorter certificate lifetimes. Online Certificate Status Protocol, OCSP, and stapling reduce client fetches and make revocation checks fast enough for modern traffic patterns. Clarify where you hard fail on revocation freshness: administrative consoles, partner interfaces, and mutual TLS backends, and where soft fail is acceptable with aggressive logging and follow-up. The rule of thumb is simple. The higher the consequence of impersonation, the less tolerance you allow for stale truth. Write it down so engineers and auditors see the same line. Key protection is not a slogan. It is custody, ceremony, hardware, and reviews that stand up months later when questioned. Use hardware security modules, HSMs, for high-value private keys across roots, intermediates, and code signing. Bind administrative actions to dual control with named humans and strong multi-factor authentication, MFA. Keep documented backup procedures with encrypted, integrity-checked materials stored separately from operational systems, and test key recovery on a cadence so the runbook ages gracefully. Log every sensitive operation, key generation, wrap, unwrap, sign, and destroy into tamper-evident stores, and review those logs with the same seriousness you bring to financial controls. Keys are the crown jewels. Protect them like it. Most organizations need both private and public trust, and confusing the two is a reliable way to create chaos. Operate a private PKI for internal service names, devices, and machine identities, and publish a documented set of trust anchors to your fleets so validation is deterministic. Model your internal validation rules after public norms, short lifetimes, proper name constraints, revocation endpoints, so developers do not learn two worlds. For external names, rely on reputable public CAs with domain control validation and certificate transparency monitoring so issuance events are visible. Keep the stories separate. Private trust rooted in your anchors for inside the fence, public trust for internet-facing names that must work for customers and partners everywhere. External trust requires more than paying an invoice. Configure domain control validation with ownership signals you can automate and audit DNS, CAA, and TXT, HTTP challenges on dedicated endpoints, and monitor certificate transparency logs for unexpected issuance on your domains. Set alerts when new leafs appear and compare them to your inventory. Unexpected certificates should trigger revocation and investigation. Teach procurement and product teams that just buy a cert comes with ownership, renewal, and telemetry duties. External issuance should feel as controlled as internal issuance, just with a different authority at the top of the chain. A living inventory ties identities to endpoints, owners, and clocks so nothing surprises you at 3 in the morning. Track every certificate with subject, SANS, serial, fingerprint, issuing CA, key length, algorithm, start and expiry dates, endpoint locations, and a named owner who will pick up the page. Connect the inventory to automatic renewal for eligible endpoints via ACME or platform APIs, and page on approaching expiry with enough runway to fix difficult cases before customers notice. Reconcile the inventory against network scans, asset management, and logs so drift appears as a ticket, not as a post-mortem bullet. An inventory that is accurate becomes the difference between routine hygiene and public incident reports. Administrative surfaces are high-value targets and deserve the toughest controls. Gate all PKI consoles and signing workflows with MFA, least privilege roles, explicit approvals, and tamper-evident logging that nobody can edit away. Separate environments for development, staging, and production authorities to prevent test paths from creeping into real issuance, and enforce change windows for policy and profile edits so a mistake cannot ripple at noon on a weekday. Build a habit of peer review for issuance exceptions and revocation decisions. When the console is treated like a financial system, the program accumulates fewer unforced errors and a lot more quiet days. Key rollover and CA replacement are not emergencies. They are maneuvers you should rehearse and document. Plan for cross-signing when you replace an intermediate so relying parties can validate both the old and new chains during transition. Stage trust anchor updates on clients and services with telemetry that proves adoption before you retire old anchors. Coordinate new certificate publication, OCSP readiness, and CRL availability before you push traffic. The mindset is calm. Rollover is a change with steps, owners, measures, and rollback conditions, not a midnight adventure. When you practice on a schedule, nobody panics when the real date arrives. Some pitfalls are so common they deserve explicit bans with practical fixes. Shared private keys across hosts expand blast radius and destroy non-repudiation. Generate per endpoint keys and keep them in local stores or HSM-backed agents. Wildcard certificates simplify issuance but magnify compromise impact. Prefer explicit SAN lists with well-scoped names and restricted key access where wildcards are truly necessary. Long lifetimes delay rotation and enlarge the window for abuse. Shorten them and automate renewals. Unmanaged test CAs leak into production through developer convenience. Quarantine them in non-production trust stores and enforce policy that forbids their use on any production listener. A page of do nots tied to a page of here is how is one of the cheapest risk reductions you can buy. Consider a scenario that rotates an intermediate CA without service impact or broken clients. You generate a new intermediate under your offline root during a documented ceremony, compute and record all fingerprints, and publish the new CA certificate to repositories and your internal distribution channels. You cross-sign the new intermediate with the existing trusted chain, so legacy clients that anchor trust at different points still validate. You issue canary server and client certificates from the new intermediate, deploy them on a small set of endpoints behind traffic slices, and watch validation errors, OCSP freshness, and handshake latencies. After a quiet period, you migrate issuance to the new intermediate broadly, while your fleet receives the updated Trust Anchor bundle. Telemetry confirms rising adoption. Finally, you stop new issuance under the old intermediate, CRL publish its serials at end of life, remove the cross-sign, and archive ceremony artifacts. No outage, no guesswork, just a practiced play. Trust models must also reflect the diversity of what you protect. For human-facing web services, public root trust and browser behavior define the bar. For zero-trust internal systems, device and service identities under your private anchors govern mutual TLS and policy engines. For code signing, offline roots, ceremony-protected keys, and short-lived signing intermediates reduce the blast radius of a mistake. For constrained devices, enrollment patterns may start with factory trust and migrate to your anchors on first secure boot with attestation. Each model should be documented with who vouches for whom, where keys live, what verifiers check, and how rotation and revocation unfold without drama. Documentation and evidence are what turn "we're good" into something leadership and auditors can accept. Maintain a PKI policy set that names profiles, lifetimes, validation steps, revocation behaviors, ceremonies, and rollover patterns, and tie it to tickets, logs, and artifacts for each key event. Keep a runbook for emergency revocation when a private key is suspected compromised, including who may declare, which endpoints get new chains first, and how you will prove to partners that the fix is complete. Schedule periodic internal audits that walk from a certificate on a host back to the issuance approval and the chain of custody for the signing key. Trust is a noun in marketing. In operations, it is a ledger. In conclusion, treat PKI as the trust fabric that must be engineered, operated, and reviewed with the same seriousness as payments, payroll, or patient records. Build a hierarchy with offline routes and controlled ceremonies. Define tight certificate profiles, automate enrollment with strong validation, operate revocation paths that reflect real-world risk, and guard keys with HSMs, dual control, and audits. Run a private PKI for internal services while managing public CA relationships with eyes open. Track every certificate in an inventory tied to owners and expiries, lock down consoles and signing workflows, and rehearse rollover and replacement before crisis forces it. As concrete next steps, direct a PKI health review and produce a 90-day plan to eliminate risky certificate practices, shared keys, wildcard sprawl, long lifetimes, unmanaged test anchors, so your trust model is quiet, credible, and ready for the next audit or incident. Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.